So in this video, let's discuss about the pre-training and fine-tuning process in transformers in generative AI, as transformers uses a unique approach separating training into two phases, that is a pre-training and a fine-tuning phase. While the classical machine learning have a one-step approach, the traditional ML model learn directly from labeled data. So the first step, that is the pre-training, the transformer gain a broad language understanding by processing vast amount of annotated data. For example, getting a vast amount of training data in the form of a text, like scraping the whole internet and giving that data to the model for training. That is the pre-training. The next step is the fine-tuning. After pre-training, transformers are refined for specific tasks. Like previously they are trained on complete internet, the data, text data available in the internet, and now they are fine-tuned for a specific task like answering to a specific question. Or another example would be in pre-training we have trained on a music sheet and now we are fine-tuning it on perfecting guitar skills after building a music foundation. This enables efficient learning. Transformers two-phase training enables faster learning and better performance, similar to attending school before college. Another advantage of it is reusable models. Pre-trained transformers can be fine-tuned for multiple tasks such as switching from guitar skills to a piano skill. What is a pre-training? Pre-training is the first phase where a transformer model acquires a general grasp of language structure, semantic and context from large dataset without focusing on a specific task. It is focused to learn a language basic before exploring specialized topics. In pre-training stage, transformers grasp syntax and grammar to create correct sentences. They learn common phrases and idioms for natural sounding text. They recognize word relationships including synonyms, antonyms and context dependent meaning, and they understand long range dependencies between distant words for better comprehension and text generation. Then what is fine tuning? Fine-tuning involves adjusting a pre-trained transformer model for a particular NLP task by training it on a smaller, specialized dataset tailored to that task. So what are its use cases? So it can be used in machine translation for converting text from one language to another while preserving the meaning and the context. Another one is text summarization. Text summarization, compressing large pieces of text into concise summarize that capture their main point. Building a question and answer, using it for Q&A tasks by providing accurate and contextual relevant responses to user queries. Named entity recognition, identify and categorizing entities in text such as names, dates or locations using pre-trained and fine-tuned model. In real-world application, pre-trained model like BERT GPT or T5 are predominantly used and adapted for various use cases. What are the pre-training challenges? Pre-training transformer models is often difficult and costly due to immense data and resource requirements. What are the pre-training complexities? They require processing of vast text data typically handled by companies like Google or OpenAI with expensive infrastructure. So what's the cost efficient and environmental friendly approach? So leveraging a pre-trained model and fine-tuning them is more practical, cost effective and environmentally friendly. So fine-tuning is a smarter approach as we adapt pre-trained model for task-specific datasets, saving time, efforts, and resources compared to training from scratch. So when to use custom pre-training? If we have a domain-specific language, if the target task heavily relies on particular genre style or a non-standard language not covered by generic pre-trained model, a custom pre-training process may be necessary for better performance. In-house data. Companies with large proprietary dataset may prefer to pre-train their transformer model in-house to better capture insights unique to their data or business domain. Custom pre-training is also useful when we have a new language or script. When dealing with languages or scripts that are not well represented in existing pre-trained model, custom pre-training can improve the model's understanding and capability to work with such languages. So that's all about the pre-training and fine-tuning process. So every transformer model is first pre-trained from a vast amount of data which requires huge amount of resources, which is very costly. And this pre-trained model is a base model which is not ready for the production. To make it a production ready product, it's then fine-tuned on a specific task. For example, OpenAI's GPT model is first pre-trained, which gives a base model, then it is fine-tuned for a Q&A task where a user asks the model some questions and the model provides some response. And these models are not as smart as a human. So there are multiple ways of fine tuning, like fine tuning it by supervised, unsupervised, or reinforcement techniques. The DeepSeek model indeed is fine tuned on reinforcement technique, which makes it better than GPT or Gemini models. And that's all for this. In this video, we have learned the two phases of transformer, that is a pre-training phase and the fine-tuning. So comment down the topic that you want me to cover in the next video. So till then, like and share this video and make sure you subscribe to this channel so you do not miss on any further knowledgeable video on generative AI. Till then, see you in the next one.